Our focus for today's lesson is going to be on estimating decimal quotients. And so the first problem that we're going to look at is on page 307. And it says a 135 and 8/10 foot of piece of construction material needs to be cut into pieces that are each 16 feet long. About how many pieces can be cut? So starting with what we know that there's 135 and 8/10 foot of piece, and I need to cut that into 16-foot long pieces. What we're looking to find is the estimate of total number of pieces cut, and I know that we're looking to find the estimate of total number of pieces cut because it says about. And when we see that word about, that tells me that I'm looking for an estimation, which means I'm not finding the exact answer. I'm finding an answer that's near it. We always look to do the best estimate. So we want to make sure that we're not overestimating too much or underestimating too little. So if we take a look at our plan to solve it, what we're going to do is we are going to use rounding or compatible numbers, and maybe both. Maybe we'll go ahead and look at both strategies and how it's going to look. Compatible numbers. So we're going to use rounding or compatible numbers first, and then we're going to divide. So we'd like to find values that are going to get us to our patterns of 10 because we worked on that yesterday. So I'm going to take 135.8 feet, and I'm going to go ahead and I'm going to use rounding first, and I'm going to round that to the nearest 10. So I'm going to do 140. And then it's going to be cut into 16-foot long pieces. So the 16 I'm going to round to 20. I'm not multiplying, I'm dividing. And so when I go ahead and I divide 140 divided by 20, I use my multiples of 10 rules that we had talked about in our last topic, and it becomes 14 divided by 2, which is 7. So it's going to be about 7 feet. Each piece would be about 7 feet. Now, if I did a compatible number, so a compatible number is I'm going to leave 130, or I'm going to take 16 and I'm going to round that to 15. And then I'm going to take 135.8 and I'm going to round that one to 150. So 150 is a lot bigger. It's about 15 away. And then when I look at this, I'm going to end up with 10 feet. And so when we look at which one is going to be the better estimate, we're going to be looking for which one that we had to change the least. So here on 20, I took this one and I went from 16 to 20. So I increased by 4, and then 135.8, which is near 136. So I increased by 4. Here I only changed my value by 1, but here I changed my value by 15. So my best estimate of the two is going to be 140 divided by 20. So the rounding would have been the best estimate for this problem. Okay. So if we take a look at our next problem on the next page, we have Diego purchased a gaming system. So let me get my board set up. For $473.89. I'm going to go ahead and write that down. $473.89 was cost of gaming system. Okay. Because I know that value is possibly going to be important. And it included tax. About how much are his monthly payments if he wants to pay it off in 1 year? Well, I know that he wants to pay off in 1 year. And it's a monthly payment. So we're going to do monthly payments. So if I look at monthly payments and I'm doing it in a year, that's going to give me a value of 12. Okay, so what I need to look on is I'm looking for the estimate of monthly payments. And how I'm going to do that is I'm going to round. We'll just start with rounding and then I'll look at compatible as well. So where I'm going to round numbers and divide. So if I use that as my plan, that's my plan. Or I'm going to use compatible numbers and divide. So either way I'm dividing, the strategy that I'm using is going to be dependent on which one I think is going to give me the best estimate. So if I take $473.89, I'm going to round that to the nearest 10. So that becomes $470. And then I'm going to take my 12 payments that I'm going to do, and I'm going to round that to the nearest 10. That gives me 10. And when I do that, it's going to be about $47 a month. And then when I look at compatible numbers, so here's my rounding. When I look at compatible numbers, I'm going to stay with 12. I'm going to leave 12 alone, okay, because I know my 12 stacks. And I'm going to look for a value of 12 that's near $473.89. So I'm going to just underline the first two digits. So I'm looking for a math fact of 12 that's near 47. So a math fact of 12 that's near 47 is going to be 48. So I'm going to take 473 and I'm going to round it to 480. And when I do that and I divide, I'm left with $40. And so we need to look at which estimate is going to be the best estimate. So here I rounded down by 3 and I rounded down by 2 here. I didn't change this value and I only went up by 7 because I didn't change this value. This one is going to be my best estimate. Okay. So this one is closer to the exact answer because I only changed one of the values and I left the 12 alone. Alrighty. Let's move into your guided practice. And so number 1 says Leo is estimating 53 and 1/10 divided by 8.4. So we have 53 and 1/10 divided by 8.4. And they said, do you think he should use 53 divided by 8 or 54 divided by 9 as his estimation? So which one is going to be the estimation that's going to be the better estimate? So if I were to use rounding on this one and I rounded to the nearest whole number or rounded to the 10. So if I used rounding to the nearest whole number, this is rounding to the nearest whole number. Okay. So this one is not going to work because again, estimation is meant to be something that we can do relatively quickly. I don't know how many times 8 goes into 53, so I would have to use the division algorithm. I don't want to use the division algorithm because an estimation is meant to be quick. So I come over here, I look at 54 divided by 9. Well, 54 is a math fact of 9. This right here, this is going to be the value to use because they are compatible numbers. So even though I rounded to the nearest compatible, I think I spelled that wrong. That's okay. Even though I used here, I rounded to the nearest whole number. I want to use compatible numbers. I totally butchered that. I want to use compatible numbers because it allows me to quickly and efficiently, right? It's about working smarter, not harder. Find an answer, there we go, that is near my estimate. So my estimate is going to be approximately 6. So if I have an answer near 6, that's going to tell me that it's going to be a reasonable value. Okay. All right. So let's take a look at number 2. So we're looking at whether or not the quotient is going to be greater than or less than 1 and why. So if I have 0.2 divided by 4, is that going to be greater than 1 or less than 1? This is going to be less. So the quotient we're looking for is going to be less than 1. And here's why. The dividend, this guy, so the dividend is less than the divisor. 0.2 or 2/10 is way smaller than 4. So because the dividend is less than the divisor, the quotient is less than 1. All right. So the dividend is less than the divisor. The quotient is less than 1. So that's a little bit of number sense that we need to just go ahead and remember. If the dividend is less than the divisor, the quotient is less than 1. If we take a look at our next one that we have, if I have 1.35 divided by 0.6, my quotient is going to be greater than 1. Here's why. The dividend, which is this guy, right? So the dividend is greater than the divisor, which is this guy. So the dividend is greater than the divisor. So the quotient is going to be greater than 1. So when my dividend is less than the divisor, so these are the two values that I look at. The dividend is less than the divisor. Answer is going to be less than 1. Dividend is greater than the divisor. It's going to be greater than 1. All right. So if we take a look at 3 through 8, we'll go through and do some practicing using rounding or compatible numbers with that division. First value, 42 divided by 6.8. So I'm going to go ahead and take the 7 or the 6.8 and round it to 7. And then I'm going to leave 42 alone because 42 is a math fact of 7. So my answer is going to be 6. So my estimation for that problem is going to be 6. The next one that I'm going to look at is going to do 102 divided by 9.6. I'm going to take 9.6 and I'm going to round this one. So I'm going to use rounding. So I'm going to do 102 is going to round to 100. And so here I used compatible numbers. Here I used rounding. My answer is going to be 10. Okay, 48.9 divided by 4. I'm actually going to leave the 4 alone. And then the 48.9, I'm going to round it down to 48 and use a compatible number. So when I do 48 divided by 4, my answer is going to be near 12. Notice each time I'm showing my thinking by writing the equation. So you need to make sure that you write your equation for your estimation so I can see whether or not you used compatible numbers or you're using rounding. Okay, 72.59 divided by 7. I am going to take the 7 and I'm noticing here that I have 72. So I'm going to turn 7 into 8 and then leave 72 alone. So I have 72 divided by 8, which is going to be 9. Okay. The next one I'm going to take a look at is 15.4 divided by 1.9. 1.9 I'm going to round to 2. And then the 15.4 I'm going to round it up to the nearest or to the next whole number, which is going to be 16. So my estimation is going to be 8. And then the last one I'm going to do, 44.07 divided by 6.3. I'm going to take 6 and I'm going to leave it alone. And then I'm going to do 44.07 and I'm going to take that to 42 because if I look at 44 in relation to 6, a math fact of 6 that's near 44 is going to be 42. So 42 divided by 6 is going to be 7. So remember that when we're using compatible numbers, which you'll notice I used compatible numbers for every single one of these examples except for this one. This one was rounding. Everything else was compatible numbers. And the reason I tend to go towards compatible numbers is these are going to give me a much closer estimate. I want to get as close as I can to my answer than rounding. So really look at using those compatible numbers. So you change the divisor first, and then you find a math fact of the divisor that's near the dividend. So 42 got left alone because it was a math fact of 7. Here I left the 4 alone, changed this to 48 because 48 was a math fact of 4. Here I changed this to 2. A math fact of 2 that was near 15.4 was 16. That's how I came up with that value. Here I did a little bit different because I saw the 72 and I said, oh, okay, I'll do a math fact of 72. So I did 72 divided by 8. So this is my oddball. In every one I did, this is my oddball. Where I left the dividend, I changed the dividend first. Typically, change your divisor first. It'll make it much easier for you when you're dividing if you remember that change that divisor first. Okay. The problems that I'd like for you to do today, you are going to do 12 through 18 even. Then you are going to do 20, 21, 27, and 28 on